In this video, we're going to continue topic 10.13, radius and interval of convergence, and we're going to look at example 3b, where we are still trying to find the interval of convergence for each power series, and we're going to be using, finding if the endpoints are included or not. So I'm going to start with my ratio test, as I always do, to find my interval. So I've got the limit as n approaches infinity of the absolute value, and I'm going to plug in my n plus 1 anytime I see an n, and I get to ignore my negative 1 because I'm in absolute value. So I have x to the 1, x plus 1 to the n plus 1 over 2 to the n plus 1, and then I divide by the original, or I multiply by its reciprocal, so 2 to the n over x plus 1 to the n. And then I'm going to do a little bit of taking it apart and rearranging it. So it looks like I get x plus 1 to the n times x plus 1, and then times 2 to the n. And then this is, I'm going to move the x plus 1 to the n up front, and then I've got 2 to the n times 2. And then we're going to go ahead and do some canceling. I know my anything to the n power is going to cancel. And then I am left with the limit as n approaches infinity of the absolute value of x plus 1 over 2. And you'll notice there's nowhere for me to plug in an n, so that's my limit. So my limit is actually equal to the absolute value of x plus 1 over 2. And again, to make this converge, we know we need it to be less than 1. So in order to take this apart, I know I have to sandwich it between negative 1. Oops, take my absolute values off. It's going to be between negative 1 and 1, because that's what being less than 1, the absolute value of less than 1 equals means. We're going to go ahead and multiply both sides by 2, so I get negative 2 less than x plus 1 less than 2. And then I'm going to subtract 1 from each side, so that makes this negative 3 less than x less than 1. So there's my interval that I'm going to start with. Now I need to test both of those endpoints into my series. So we're going to test x equal to negative 3 first. So when I plug my negative 3 into here, we would get negative, or the sum as n equals 1 to infinity of negative 1 to the n. And then negative 3 plus 1 is going to be negative 2 to the n over 2 to the n. I could rewrite this as negative 1 to the n, and this negative 2 could be written as negative 1 to the n times 2 to the n, right? Because if I take that negative off, I'm sorry, not to the n, just to the first. It could be written as negative 1 to the first. So really what I have going on here is that my 2 to the n's cancel, and then when we are multiplying, remember we add the exponents. So I really have n equals 1 to infinity of negative 1 to the n plus 1. So that's what my series simplifies to. I am going to try using the nth term test. So I know the nth term test is the limit as n approaches infinity of negative 1 to the n plus 1. So when I plug infinity into there, I would still get something along the lines of 1 or negative 1. All I know is it wouldn't be 0. So on nth term test, as long as it's not 0, let's see, where's my test? As long as it is not equal to 0, we know that it diverges. So therefore diverges by nth term. Which means that I just have a less than. There's no equal to on that one. All right, let's try plugging in the other number. So my other value is 1. So at x equals 1, and again, we're going to plug into this series. We've got the sum as n equals 1 to infinity of negative 1 to the n times 1 plus 1 is 2. So I get 2 to the n over 2 to the n. And I notice that that cancels. So I get the sum as n equals 1 to infinity of negative 1 to the n. And I am going to use it looks like I tried to use the geometric series test. But I can't really do that with this one because it's alternating. Let's try the alternating series test. So if I do alternating series test, remember I have to, my limit as n approaches infinity of negative 1 to the n has to equal 0, but if I go negative 1, oh, I know why I do geometric, because look at what happens. I get that it doesn't equal 0, so it's inconclusive. So that's why I did not use alternating series. So let's try the geometric. So geometric, I know that my r would be equal to, because it's supposed to be the absolute value of r, would be equal to negative 1, so it's going to be equal to 1, which is greater than or equal to 1, so therefore it diverges by geometric series test. So I would have no equal to on this one as well. So in this one, the endpoints would not be included.